Okay, now we're going to add one more thing to this idea of position and velocity. It's called acceleration. Excuse me. But we're going to do this quick test first. We have graphs A, we have graph B, and we have graph C. And they are all position time graphs. So if you were to look at these, I think that you should pause the video and decide which one of these is a velocity increasing, decreasing, and or staying the same. So you should pause it again, and again you should try to distinguish, based on the positions here, where is the object speeding up, slowing down, or moving at the same speed. Okay, so looking at graph A, we have someone going backwards here. That's what this means by going down. If you're going to check out the slope of any one of those points, though, it's all going in the same slope, right? And so here the velocity is constant. Yes, we're going backwards, but we aren't going backwards any faster or slower than what we were before. So taking a look at this here, if you were to look at all of these slopes here, these slopes are getting steeper and steeper and steeper, meaning the velocity is getting steeper and steeper, or it's getting larger and larger. So here the velocity is increasing. And now this object here and the last one here is still going forward, but if you connect the lines here, these slopes are getting slower and slower. So it is going forward, but it's going forward slower and slower and slower, meaning that the velocity is decreasing. The number one thing that gets confused in these graphs is that a decreasing velocity doesn't mean something's going backwards, or an increasing velocity doesn't actually mean that it's going forwards. Velocity changes doesn't necessarily mean that it's switching direction, which might be the hardest thing to remember. So what we're noticing here is acceleration. Here there is no acceleration because it is not going faster or slower. Here, the acceleration is positive because it's going forward, and it's going forward faster and faster. Here, the acceleration is negative because even though the object is moving forward, it is moving forward at a slower and slower rate. And so we're going to try to draw some more of these graphs to kind of wrap our head around this. Let's imagine that this graph here is a runner in a race. Alright. Okay. So this is going to actually be the velocity versus time. This is a VT graph. Okay. So between the beginning of the graph and this point, in this time period here, we know that the velocity is 0. The race hasn't started. He is standing, or she is standing at the beginning line, the starting line. So acceleration is 0 too, because we haven't started getting faster or slower at all. Now let's talk about this case right here. Now velocity is positive. They started the race. But there's also something else going on. There is an acceleration here. Because not only did they start running, they're running faster and faster until they reach their max speed. Now between this point and this point here, the velocity is positive. He is going forward with a certain speed, a certain velocity. But the acceleration here is 0 because we are not going faster or slower during this time period. Our speed is remaining, our velocity is remaining the same. And then between this and the last part right here, velocity is still positive. We are still going forward, but the acceleration is negative because we are starting to slow down. If this was the end of the race, they're starting to slow themselves down to a stop right there. So, this acceleration graph can be kind of tricky sometimes. And if I were to draw like an acceleration graph here, the red here would be acceleration over time. Acceleration is 0 here. Acceleration is positive here. Acceleration is 0 there. And acceleration is negative because it's decreasing. So that's something that you have to get used to when you're doing these graphs. And there are no numbers involved for this concept. You just have to be able to kind of picture whether it's positive or negative. So let me give you one that you could try yourself. Now I'm just going to freehand sketch a graph to have you visualize an object moving. And I'll put a few points here in the graph. Oh, and we should put a point. Should put a point right there and also right there. Okay, so you can section this cell up into A, B, C, and D. Now in each one of these sections, see if you can identify what velocity and acceleration is doing. And then, after you've paused the video and done that, come back and you can check our explanation here. Okay, I need to say here that actually regions A and B, if this is a velocity over a velocity time graph, regions A and B are going to be the same. That's my mistake. But so from A to this point right here, in these two regions, velocity is always positive here. And acceleration from here to there, that means that our speed is increasing. So we are accelerating here. And my apologies again, I made a mistake. From here to there, they aren't the same because actually our speed is starting to slow down. Or rather, the speed, the velocity is still increasing at a slower rate. Anyways, our velocity is still getting larger. Acceleration is happening. So actually, yeah, jeez. Go backwards and forwards on that for a little bit. But these two are actually going to have the same positive, 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 positive. So the similar with these two right here, if you couldn't find a difference, it's because they will have the same idea. They're both positive velocities. These things are, the speed is still going forward, but we are decreasing our speed. Our speed is going down a little bit. And then lastly here, our velocity is still positive. We're still going forward, but we are accelerating again. So I'm sorry for that confusion there. But hopefully this is making a little more sense. Now I have one last example. This I'm taking from the book. We're taking a puck from hockey, and we're imagining someone is taking a shot. We're going to have three different graphs: xt, vt, and at. Alright. Now, xt would be something like this. Suddenly and very quickly, the puck starts sliding forward very quickly, and then starts to slow down a bit, and after time, it levels off and it stops, kind of. Okay, so it traveled really quickly this far. So I'm going to put a couple points here to help us with this a bit. We'll just put A, B, and C. Now, if we're looking at the speeds at every one of these points here, the velocity right away with this puck is super high. It's going super quickly. And so at the very beginning, this velocity is high, and then it starts to slow down quite a bit. So this might be A. The speed is still high, but then it starts to slow down here. The slope right there starts to get a little more shallower. And so B might be right down here. And at Z, there's almost no slope at all. It's almost completely flat. So at C, there's almost no velocity. Now that makes sense because at the beginning of a shot, we should have lots of speed, and the speed should start to slowly get rid of itself as time goes on. Alright, and then for acceleration, if you think about it, it is increasing its speed super quickly. And so there's this slap shot where it is increasing speed a lot, but then it gets to about this point A where it's not increasing at all, it's actually decreasing. From about here all the way over, our speed is going down, our velocity is going down, so we have to have an acceleration that's going down underneath. And there we go, we have sudden acceleration, but then a deceleration in this area right here, because there isn't some friction on the ice that slows the puck down, and so the puck will slow down all the way until it stops at C. Okay, so that was not my most eloquent explanation, but hopefully this is making a little more sense. And again, I strongly recommend that if it's not, that you go on YouTube and look at the suggested links and follow some other explanations of this, because these relationships really help you when we go further into the equations.